the mathematical property that we know as a sine function is a function of the height of a point on the circumference of a circle. We have a line at the center of a circle that is 100 steps long and a dot on the end of the line. When the line is at 90 degrees, the height of the dot from the midline of the circle is 0. As we turn the dot, the height increases until the line is vertical. At that point, as we begin going back down the other side of the circle, the value of y, that is the vertical position of the dot, decreases until it becomes 0 once we reach 270 degrees. As we continue, the height becomes negative until it becomes minus 100 at 180 degrees. Finally, it moves back towards 0 as we move back to the original position of 90 degrees. Now, the relationship between the sine function and a sine wave is going to be easier to see if we record some of the dots. And we can do that by creating a table. And as we sweep the dot around the circle, just as we did before, we'll just record the position or the height of the dot at each point on the circle. And if we do that, we see that we start out at 0, and as we go toward the top, we eventually reach a maximum of 100, and then start going back the other way. We can use this to generate a sine wave. If we put the pen up and move the sprite to the left side of the screen, then we can graph these values, and it turns out that as we go toward 100, we increase. As we come back the other way, we decrease, continue to decrease into the negative, and finally wind up going back towards 0 as we sweep around the circle. So we're just graphing the height of the dot on the circumference of the circle as it moves around the circle. And if we do that, we get a sine wave. Now the sine function is actually the height of the dot, or the height of a point on the circle, divided by the radius. But since the line, that is the radius of the circle, is 100, then we just shift the values 2 places, 2 decimal points, to get values between 1 and 0. And that is how the sine function is generated. Now, we can use this to create a tone. However, a single cycle of the sine wave is not going to be sufficient to generate a tone of any length. But we can copy the single cycle and append it to a second table, and just keep adding to the second table until we have 200 cycles. And so now we're gradually building up the table. Since there's 24 points in a cycle, 200 cycles yields 4,800 items for 200 cycles. When we play a tone through the speaker, the voltage in the electrical current is used to generate a magnetic field that moves the cone of the speaker back and forth. However, these values are typically much smaller than the values we have in our table, but we can simply multiply every item in the table by, say, 0.001, and that will generate a table of smaller values. So we're going to take this table, 200 cycles, and then use it to generate a second table with smaller values. And once we do that, now we have a table that's identical, except the values of the decimal places have been shifted over to the right. And now we can play the tone. As you can hear, this is a fairly low tone. It's actually a 200 hertz tone. We know it's a 200 hertz tone because we're playing 200 cycles in 1 second. By way of comparison, the note A above middle C that orchestras use to tune with is 440 cycles per second. So we can now see how a sine wave is generated and how we can use it to generate synthesized music. We can also use this to do other things like drive a linear motor.